Hi folks, it's Ron. Hey, and welcome back to part two of residential structured wiring systems. And in this portion of it, I'm going to talk about what the residential standard actually says about actually wiring the home properly. And if you get a chance to buy the standard, you'll find out it's not a huge document, but it talks a lot about how you go about wiring the home properly for low voltage applications, at least the minimum they would expect out of you, I'll put it that way. And that's basically putting phone, data, and video in all rooms of the house. And you'll find the standard was written for anything basically under 50 volts. So all these applications kind of apply by the standard. And you'll find out that the standard was written not only for new construction, but remodel as well, and single and multi-tenant. So if you bought a copy of the darn standard, it would talk a little bit about how to actually go about wiring up a house for, for like an apartment complex or something like that, okay? Or a high-rise building. Now, the customer comes up to you and is wanting to remodel the house or build a brand new one, and they ask you the basic question, which is, "Hey, what would you recommend I wire the home for?" At a minimum, kind of thing. So the answer to your customer is actually what we call grade 1 or grade 2 wiring. Now, grade 1 wiring means we're going to put an outlet in all rooms of the house. So all rooms get at least one outlet. If it's a large enough room, we'll put more than one outlet in that room. And grade 1 wiring is where we're going to put one category cable at the outlet and one piece of coax at the outlet. Okay. Now, as far as the category cable is concerned about which ones you want to install, the recommendation today is Cat 5e at a minimum. We recommend Cat 6. Years ago, this used to say Cat 3 recommend 5e, and somewhere down the road, is this going to say Cat 6 recommend Cat 6a? I can almost bet you it will, but when that happens, I can't really tell you. But so minimum Cat 5e and at least one Category 6 cable, or one of the two, I should say. Now, the coax at the outlet in the room is typically RG6. Actually, RG is an old military term. It stands for radio guide, actually. And if the standards actually call it Series 6. So if you ever hear anybody mention the Series 6 coax, it's the same stuff. Now, why do you want these two cables at the outlet in the room? Well, the coax is there to bring video to the room, cable or satellite, one of those kind of applications. The category cable can be used for phone or data, and the key term there is or, not and. And a lot of us may know you can't actually mix phone and data on the same piece of category cable. If you look at Ethernet today, and virtually all networks in the world run Ethernet today, probably 90+% of all networks run it, including the internet. You'll find in 10 and 100 base T data networks, which are very, very common in the industry, and again, think about how fast your high-speed internet line coming in from a cable company actually is, which is usually somewhere in that range. They only actually use 2 of the 4 pairs to make that work. Pins 1 and 2 are a transmit pair, and pins 3 and 4, or 3 and 6 is a receive pair. And so the computers are not using all the pairs in the cable. So could you technically take some of those pairs that are not being used and split one pair out to a phone jack at the outlet of the room and split that pair back out at a panel and feed that to a phone board and put phone across one of those pairs? And the answer to that is yes, you could. And you might have a little interference when the phone's ringing, but other than that, it's probably going to be working. And in a pinch, could you not technically take both those pairs not being used and terminate those 2 pairs into pins 1 and 2 and 3 and 6 in a second category jack at the outlet in the room and basically do the same thing back in a panel and basically put high-speed internet to 2 computers across that? The answer is that yes, you could, and it'll work. Now, one of the reasons we tell you not to do things like that is because of the future applications, and gigabit Ethernet is the next rung up the ladder, and you'll see it's using all 4 pairs of the cable. Now, and partly how it gets faster is it starts using all 4 pairs of the cable. And we're actually transmitting and receiving on all 4 pairs. So as gigabit Ethernet becomes popular in the home, that's going to be a problem because we need to use all the wires. Now, when will gigabit Ethernet become prevalent in the home? Again, I can't tell you that one either. And but if you follow people like Google and what they're doing down in Kansas City with Google Fiber, and they're doing this down in Austin and someplace I think out in the Salt Lake area as well too. But they're bringing fiber to every home and business in those cities in Kansas City, and they are going to be the first gigabit data network in a metropolitan area in the country. And I think what Google is trying to do here, in fact, I know what they're doing, is they're trying to beat all the other service providers to gigabit Ethernet, which at this point in time may not have a whole lot of services needed for that in the home, but as things go on, it's going to definitely happen. So that's one of the reasons why we tell you not to do this. And the real answer to people is that instead of grade 1 wiring, what we really want you to say to them is grade 2 wiring. And here's an example of grade 2 wiring, where we've got 2 catenary cables at the outlet of the room, and we got 2 coaxes at an outlet of the room. And the coaxes, it's again RG6, and one of these coaxes can be bringing video into the room. The other one can take video out of the room if you had a nanny cam or some video source you might want to share. You will find applications that require 2 coaxes, and for a lot of years, even today, satellite companies, if there's a DVR or a TiVo type of unit associated with that system, they need a second piece of coax at the outlets in the rooms. And you might be thinking we're trying to sell you lots of wires here, and in a way we are. And I tell people the wires in the walls are the cheap part of the installation. It's what you hook to the darn wires. It gets expensive. But we're going to err on putting lots of wires in walls if we can. And the catenary wires, one's phone, one's data, although they can be both phone or both data, but that's kind of the intent. So grade 2 wiring is really what we want you doing and selling to people here. Now, you'll see on the chart here that it talks about fiber optics as an option. You know, we've been talking about fiber optic cable coming into a home for a lot of years, and it still isn't here. But more and more service providers are bringing to the home with fiber optics, and it's just a matter of time before it comes in. And fiber gives us this ultimate bandwidth. We don't really know the upper end of it, but I guess if I'm building my dream home of the day and I plan on being in that thing for 20 or 30 years, should I think about fiber? And the answer is probably yes. And you'll find out that the cabling, and you can get this cable all in one bundle where it's 2 coaxes, 2 Cat5e, and a pair of fiber in it. All bundled together, and you'll find that the fiber optic stuff is not really all that expensive to terminate and install. It's the electronics that on the outside that gets a little more expensive, but it's something to at least think about in your home. Okay, so grade 2 wiring, that's what you want you to actually install. Now, we want you wiring all rooms of the house too here. And, the slide here says bathrooms, and I'll be truthful with you, the darn standard here does not mention bathrooms. But I tell you what, when I go to these trade shows and I see what these guys are doing in bathrooms today, it's amazing. The mood lighting and the music packages, and have you seen the TVs that are mirrors, and if they turn them off, they're a mirror, and turn them on, they're a TV, and they got some pretty fancy toilets going on, and shower stalls, and so all kinds of stuff going on. So what the heck, wire up the bathroom. And we also want you to make sure you're using backless type boxes. And here's an example of a backless type box. Code does not require a back box. And the reason we don't want a box with a back is because normally that slack at the outlet, they're going to wad it up and shove it into the back of the box, which just knots it up and kinks it really bad. So we want to try and avoid that if we can. Okay. The standard also suggests to you that if the room is big enough that we would put more than one outlet in the room to eliminate the need for extension cords. Kind of like the code book says about electrical outlets, same idea. So if that room is big enough, we would actually then pull 3 different poles to this this room itself. And that's 3 separate poles, what we call home running of cable. It's a dedicated line of wire. We're not daisy chaining wires in any way, shape, or form anymore. Some contractors might refer to it as star wiring, where we come from a central point like our low voltage panel, and we wire to each individual outlet separately. So, and no splices can be happening in those runs. If you cut the wire accidentally or during the installation, technically we're going to ask you to pull new wire. So no splices in any of those home runs out to the outlets in the rooms. Okay. Now, grade 1 suggests to you that you don't necessarily need power near the low voltage panel you're going to install, which is kind of crazy. I think you're probably going to need power nearby. Grade 2 suggests that you have a dedicated circuit for the panel. Now, keep in mind these are standards, not codes, so you don't have to follow what this thing tells you. And so I definitely feel like you need power there, but I don't know if I go to a dedicated circuit for it. But and when you look at these outlet receptacles and things like that, you'll find, like in this one here, was a power module that actually mounts in the bottom of one of those panels. And the blue receptacle indicates something here, which is surge protection. And just a little bit on surge protection. I tell contractors that if you're not installing whole house surge units in people's homes, you're missing the boat on an opportunity here. You can run out and buy them for $100, $150, whatever they are. They wire into any 2-pole breaker in an electrical panel. It's pretty simple to install. You can protect your power lines through those. You can run your phone lines through those for protection. They tell you can run your cable TV lines through them, but watch out. You'll find out no cable companies recommend surge protection because at times that device can actually filter channels on them, so that's why they don't like it. But Anyway, but surge protection is a good idea, and I tell folks that if you've never experienced a large surge in the neighborhood, and you'll know the value of decent surge protection when you do, because anything with a microprocessor is susceptible to a surge in the neighborhood. And if you've ever lost a treadmill or a microwave or TV or something like that, you'll know the decent value of good surge protection. And I tell folks, if you go out and buy that fancy TV someday, and you need to hook that up with some new cabling, and the person in the store tries to sell you that $300 set of cables, because that TV's never going to look good without this $300 set of cables in it, I tell most folks buy the $30 set of cables and put all that other money in surge protection. You'll find that's actually pretty good use of your money. You'll find a lot of these cables that you see sold out there in the audio video world, a lot of it's kind of good marketing. Okay, so anyway, grade 2 wiring, definitely want to have power nearby the panel. Now, when we talk about grounding of these systems, by code, you have to ground all your low voltage wires as they enter the building. But the first thing I'm going to tell you is check with your local code people. I don't live in your neighborhood, so find out whatever the local code people are making you do as far as grounding is concerned in the building. But again, as a general rule, all low voltage wires need to be grounded as they come into a building. And you can't take this with just a typical ohm meter. You've got to actually have a earth ohm resistance kind of meter, what they call a megger type tester. And there's several variations of meggers out there. And it's interesting, the code book says if you drive one ground rod on the outside of a home, Mr. Electrical Contractor, you're required by code to actually measure the impedance of that ground, which should be under 25 ohms or less, and usually it's quite a bit under that. And virtually nobody does this. And in '08, when the new code came out in '08, it basically stated that if you drive 2 ground rods 6 foot apart, bond them together, that automatically ought to be under 25 ohms. You don't have to measure that. So a lot of the country has gone to 2 ground rods. But I find more and more people go into what they call the UFR grounds, which is the name of the grounding system. And it's actually using the rebar and the concrete to actually make that ground connection. And they figure what the heck that thing's going to be there the life of the building. And, a number of years ago, a study is done by ground rods on what the useful lifespan of a typical ground rod is. And you know what they came back at it? It was 12 years, and I'm sure you guys replace your ground rods on the side of homes every 12 years. So anyway, be aware of that, all right? So whatever they're telling you to do, you do, okay? Now, today, it is required by code, again, that we ground all low voltage wires, and there are a myriad of ways of doing this as it comes to the building. And here's just one example. This is basically a block of aluminum you can mount on the side of a building, and you can run a number 6 conductor off this to a ground rod, and then ground your cable TV or your satellite or whatever it is as it comes into the building. So some of these will mount right to a meter base at the local utilities to let you do that. Others will have to be mounted someplace else on the side of the house and then grounded as well. So again, check with your local code people as well, and make sure that ground is supposed to be, again, 25 ohms or less. And again, gas lines, steam lines, hot water pipes, all those things are really not considered ground rods, okay? All right. Now, if I was going to explain to you how I get wire from the side of the home into the house and then, into a low voltage panel, then out to the different outlets of the house, that's what the schematic does. And the schematic comes right out of the standard, so I didn't make this thing up. And we always start on the outside of a home at what's referred to as the demarcation point. And essentially, the Demarc's on the same side the electrical panel comes in, or electrical service comes in, and a Demarc is where they own it, and from there on in you own it. So gas meter, electrical meter, those are great examples of Demarcs. For a phone, it's been a great looking box like this for I don't know how many years, but a lot. And prior to that, it was like a porcelain terminal shoved up underneath an eave. And your cable company back in the 70s and 80s would throw a splitter in the weather out there like that, and that is no longer done anymore. They put their own little gray box. And so we're going to find a route from this position into the pan or into the home and then or building or into the low voltage panel. And I generally tell contractors, as a general rule, always hide your wire. Put it in conduit if you have to. Don't leave it exposed on the outside of buildings, because people do stupid things like accidentally cut it, paint it, hang your Christmas lights from it, all kinds of stupid things. So always try to make sure your cables are covered up and not exposed, okay? All right, so we find a route into the house and then into where we're going to put a panel. Now, the the standard would suggest to you that you install what are called auxiliary disconnect outlets inside of the home. Okay, Now, the ADO is essentially just an outlet. It doesn't have to be anything fancy. It can look like just one of these little connections right here. And essentially what the ADO is a testing point for in the home. And if you can imagine, if there's a service problem in the house and you don't know if the problem's in the home or outside the home, and say you're looking for phone service, and this outlet's someplace in the house, and I'm trying to figure out, do I have service inside the home? I can take a tester or a phone and go to this outlet and see if I have dial tone. And if I do, I know service is coming into the building. Now, it is also meant for like an apartment complex. This is an outlet in the apartment that the tenant can go, you know, I don't want the cable or the satellite or whatever the heck the service is, and actually physically disconnect themselves from it in the apartment versus having to go out all the way out to a Demarc to do that. So that's all the ADO is meant to be, more or less a testing point. Okay, now the distribution device, as far as it's concerned, the panel itself. Now, technically, you don't need a panel. I mean, you can slap everything on a piece of plywood someplace and it'd be just as effective as putting in a low voltage panel. And I like to tell people there's probably 30 people making panels today. And once you get your arms around one, you're going to get your arms around all of them. So they're not all that hard to actually install. And the panels, we would like to put them in climate-controlled environments. No attics, no garages, no exterior storage type of locations. And part of that is the hot and cold. But really, the real reason for doing it is corrosion. And all these connections inside those panels are made out of copper wire. What's that copper wire going to do over time? Well, it's it's going to corrode. So we want to make sure it doesn't do that. So and by the way, the entire world has gone to compression coax connectors, and why have they done that? And part of it is because they have O-rings in them, and they can provide a certain amount of water tightness. So we like to put them in climate-controlled environments, folks. Okay, and so no attics, no garages, or again any exterior storage type locations. And there are a number of different type of panels available to you, but we typically find these in closets, master bedroom closets, mud rooms. Laundry rooms, those kinds of places. Could you not mount this right next to the electrical breaker panel? And the answer to that is yes, you could. Nothing says you can't. It's just not maybe the brightest place to put it because you got all that electrical wiring that you're going to have to cross to get to your low voltage wiring. So keeping some separation from power is always a good idea. So find a place to mount that darn panel, and then we're going to run wire from it to all the different outlets out there. Okay, now. The horizontal cabling in walls, what we call it, is what's referred to as the permanent link. So again, we're going to have a dedicated run of cable to every one of these outlets in the house. Okay, and it's home run or star wired, as was said before, and it's referred to as the permanent link, or again the horizontal cabling in the walls. Now. There's a length limit here of 90 meters or 295 feet. Now, first of all, in single-family homes, are you ever going to hit 295 feet? And if you do, you're wrapping wire around a house. And if the guy does have a house that big, well, he's got a big house, okay? Now, in an apartment complex or a high-rise building, could I hit 295 pretty fast? And the answer to that is pretty yes, I could. And you're going to be wondering, where does this rule come from? Because, if you're using telephone wire for old analog wire phone circuits, you can run that 1,000 feet and probably make that work. Cable TV guy, when you tell him you got to go 295 feet over RG6, he's going to say, whoa, probably going to have to amp this, but I could probably get it out there to you. And where the number actually comes from are data guys. And certification testers, which are testers we use to test data networking cable to make sure it's actually capable of supporting whatever speed we're trying to get out of it, will measure the length of the cable. And you'll find that all these routers and switches and these devices that make all these computers talk to each other, they're all designed and engineered to be able to work around 90 meters of category cable. And so it's their design limitation is where this number comes from. And so my meter might say 95 meters, and it would technically fail the test. And I tell people, well, what are you using the wire for? Could you go longer than 90 meters? And you might be able to. So, but that's where that number actually comes from. So could you go out and buy basically 300 foot of category cable and put a mod plug on either end of it and plug one into a router and snake it along the baseboards and eventually plug a PC into the other end of that cable? And should that work? And the answer is it should. But that's where that number actually comes from. Okay. Now, they also give us another 10 meters of cable outside of the walls for patch cords and things like that, for jumper cords in the panel, or patch cords going out and plugging in whatever the device is out in the outlet in the room. So the actual number is 100 meters, which is 328 feet. And, if I ever go past this 90-meter rule, you can do it. It just costs you a little bit of money because you'll have to put another router or switch out there that takes it the next 90 meters. And you cannot do that endlessly, but you can always get around the 90-meter problem if you have to, okay? Now, from the panel out to the Demarc, we will also give you another 50 meters of cabling. So the standard basically says from the side of the home to the furthest device in that home, you're not supposed to be past this 150 meters or 290 or 492 feet, which is actually a very long run. So, especially for single family, okay? So that's what the standard says about how to actually lay out and actually install these panels inside these homes. Hey, thanks for watching, folks. Do me a favor and go check out my YouTube channel. I really appreciate you watching that thing. And hey, thanks for watching this video. I'm Ron with Ideal Industries, and I hope you learned a lot. We'll see you in the next one.